I got my hat on. Started my hair. You've started recording? Oh no! Now I'm under the gun. Okay, all right. This is W1REX, Rex Harper, and I'm just going to go through the building of the 20-meter center board. Couple of things first. Introducing. We don't really need very many tools. Soldering iron, pair of needle nose, pair of flush cutters, maybe a lead forming tool if you need it. Most important thing is a board holder. I'm going to go off camera for a minute. No, where's our board? Oh no. Some guys have big gummy things like this to hold. Oh, let me get the board out. Okay, I'm going to fish it out of this bag of parts here. Come on. Help me, Rhonda. Okay, here's a board. They would put it in there for tighten it up and everything. This thing weighs a ton. Who in the hell wants one of those? So, I invented something that I use called a brass set, and they just four little brass. Oh, bring it over the other camera. I've been told, been prompted. So I made these little guys, and they're just four little brass blocks that go on the corners, and now you can turn that board upside down, and it's going all over the place to solder. You can put it upside that way when you're putting the parts in, and that's much more convenient to carry around than other things. So we're gonna now take the parts and figure out what we got. There is on the schematic, the current schematic sheet, there is a bill of materials, complete bill of materials, but of course, you gotta identify them and separate them. So one of the things I do is, if you do your sorting and checking beforehand, you can make the bill a lot faster. So I'll just basically separate all the stuff out and sort the things that you can see, pull the things out that you know very quickly you can identify. So here's nuts, bolts, washers all over here. Whoops. Here's a transistor, I guess. Okay. And here's some things that look like resistors. And I'll put that hardware over there. Here's another resistor over here. So I'll put those over here. A couple of little things. Those little adjustable shorting blocks they made up with a header connector. That goes to the crystal. And we have some solder connections that go to the header. There's a female shell, there's the male, and there's the terminal pin, so that's all one thing. Oh, there's another one over there. A couple of capacitors. And I'm looking, and those go up there. Transistor here. These things, there's three kinds that are like green that are tubbier than a resistor. They look like resistors, but they're not. They're axial chokes. This funky little thing that's red with a couple of things on it, bands on it, that's a choke. And now we're left with 5 resistors. Looks like 4 chokes and a bunch of capacitors. A header, a couple of jumpers, battery snaps, terminals. So now I can slide this to one side. And one of the things I can do is go back to the resistors. Whoops. I just moved off camera, didn't I? Oh. Okay, I'm fine. All right. Okay, so what I'll do is I'll take these resistors, and there's brown, black, orange. That's 10K. I'm going to put them in order. This 5-1 brown, green, brown, black. That's 51. Here's a brown, black, brown. That's 100. Brown, black, orange. That's 10K. And there's a yellow, violet, red, which is 4.7. So now they're in order. I can do the same thing with the axial chokes, but I'm not going to worry about those. Capacitors, here's 3 on a thing, so I know those are the same. I'm going to look at them, and they're Those are 223s. I'll take my okay. So by sorting all the parts out the first time, right off the bat, it eliminates having to search around for them as you build. So in this case, I got a piece of paper and I'll mark these are 223, which are 220 picofarad. These are 104s, so they're the 0.1 microfarad. This guy right here is a single, and I can read it's a 471, so that's 470 picofarad. I'll put him right there. And this guy here is the last one on the list, which, geez, I can't read because it's too dark in here. What's the last one on the list for capacitors?
0.1 microfarad?
No.
No, 68, 220, 470, and 0.1.
This must be the 68.
So 680.
680?
No, 68 picofarad.
68 picofarad. So we'll put him there. He's an awfully big 68 picofarad. Okay, so this was 51 ohms. This was 100 ohms. This one was 4.7K. And these were 10K. So I've got the parts all sorted out. I'm going to very carefully slide that over to one corner. I'll get my board out. And when I'm building, if you don't have anything, let me take these off for just a second and show you. When you don't have anything and anything to hold the board and you're trying to just work on your bench, you're going to try to put things in to keep the board flat when you're soldering. So I'll go after the resistors first. So when I put them on, the board stays pretty much flat. So in this case, I'll put, and I'm not going to build it for the schematic. I'm not going to build it for testing purposes. I'm just going to build it by the height of the component, which is generally what I do. I'm going to take the resistor, I'm going to put it in the lead forming tool, I'll bend it, and I've got it at now 0.4 inches, which happens to be the spacing I selected on. That's a standard resistor spacing, so I can put it right in there, slide it down. I'm holding it in with a finger, and I can just bend the leads just a little bit back and forth. I'll pick another one, 100 ohms, I'll do the same thing. I will form it. And I'll find out where it goes on the board. And it goes right here. Same thing, I'll pull it in with my finger, pull the leads apart just a little bit so it can't fall out. Next one is a 4.7K. That goes pretty much right next to it, I believe. Well, a couple of slots over. We got a 10K. Goes in between the two. Now I could be quite, some people like to have the colors lined up just the same way every single time. I'm not all that crazy about having it look perfect. So we're down to the last resistor. So here we go. It's the fifth resistor. So as you can see now, I put five resistors on the board. Then I can start soldering. And I purposely took those things off because I can show you that when I put this board down, it's as flat as it's going to be, especially if I'm going in this area right here. When I get to the edges, that's when it starts getting kind of crazy. But in this case, I'm going to put my four little blocks back on. And you can see it's quite simple. These are nylon screws, so they don't mark up the board, so I can just put them anywhere. Come on. So now I set that board down, and it's just perfectly stable. You get a nice iron, hot iron, good tip. Clean it nice, so it's nice and I need some solder. In my portable operation, I always keep my solder in a plastic bag because you want to keep it clean. You don't want it to get dirty because dirty, filthy solder leaves a lot of crud all over your board, and sometimes it's hard to solder. You don't get nice, clean connections. So again, I'll go through the process. I got a nice, I don't know if you can see that tip is nice and clean. And I'll put a little dab of solder on there so I see a little drop. And I can see the bubble, the bead of solder on the end. And when I go down, I can spin this board to find the perfect spot to put that bead of solder on the lead and on the pad. That transfers the heat from the iron to both the lead and the pad, and I'll feed that junction. And that's it. And you can see it. I don't know if you're going to be able to see this. I'll try to bring it up close to the board, close to the camera. There's a really nice little bead on there. It's nice and shiny and perfectly formed. So now I can move this board all over the place. I have a habit of cleaning the tip. Add a little bead. Put it in there. You wait just a second, then feed the junction. And that's it. You don't want too much solder. You don't want too little solder. I can go way over to the end. I can get right in here. In this case, I didn't have to clean it, but put a little bead in there. And I can see it start to wick, and that's when I add just the extra little solder to make it happen. Okay, we took a break for a second. We changed the camera angle. Wait a minute, let's see how close up that is now. Oh man, that's really tight, but unfortunately all right, so we're back to that camera right there, I think.
I believe we are recording.
Okay.
Again.
All right, we're recording back on that camera.
Yeah,
Okay.
We were paused before.
We took
Recording
a couple of breaks here to get a better setup on being able to show this this operation in close up. So now I've got a new close up camera coming down on this baby, and now I can do some soldering, and you can see what the heck's going on. So again, I'm gonna move this in. Let's see. Can you see? Yeah, okay. There's my little. Some people use a paper towel that's wet. Some people use a sponge that's wet. The problem with that is when you actually clean your iron, that moisture, the water, takes a bunch of heat out of the iron and cools it completely down again. You changed cameras on me again. I was explaining it towards the. So anyway, so the idea of brass shavings is the fact that when you clean and wipe the tip, you're not taking heat off the iron, so the iron stays as warm as it was when you cleaned it. So now you can put it out of the way, and now you can add a little bit of dollop of solder, and let's get back to my little prompt point. And now I can clean, and I can go right in there, and I'm watching that. I can see that dollop wick over to the components. And you just feed just a little bit. You don't keep feeding a ton of solder. You just give it a little bit. Now I'm going to spin the board around so I can get into these other 3 points. I'm going to clean the tip again, add a little dollop, and I can do 3 more points. 1, 2. Now I'm actually watching my iron, and I can see that I haven't lost that little dollop that's on the end of the iron, so I can just keep on soldering. So did we get 1, 2, 3, 4, 5, 6, 7, 8? There's 10 leads all soldered. So I can now take my flush cutters. I'm using the close-up. Let's see. Flush cutters are perfectly, see, they're ground flat on one side and have the slicing action going down to that flat. So when you cut off the lead, it's just flush to the board. And that's what we want. We don't want any like razor stubble. Like when you're shaving and you got a dull blade, you get razor stubble. It's like, hey, did I remember to shave this morning? So another important thing to do, I'm going to fluff these up a little bit. I've seen this time and time again. People will go in there and they'll cut that lead off and it will go flying. That is not cool, because even if you're wearing protective eyewear. In my case, I'm always wearing protective eyewear, but it doesn't protect around the corners and stuff. Plus, I find myself billing in hotel rooms a lot, and you don't want to leave these things all over the carpet because some poor sap's going to come in their stocking feet, and sometimes that poor sap is me in the middle of the night and step on one of these things and get inoculated. So you always put your spare finger on the end of the lead, clip it, and it falls away, and you collect them so that at a later date you can collect them all up and put them in the trash where they're supposed to be, not on the floor. It's just good etiquette. So, and it's the safe thing to do. And if you look, see if I can show a good side image of that board. Let's see. I'm trying to get it in the. You see that on the underside, there's very little leads sticking up. They are cut pretty close to the thing. You don't want them poking up. Now, I can set these over in a little pile, and I can continue. So in this case, I'm going to put in the things that are similar to resistors. I'm going to put in the axial chokes because they also are close to the board. So in this case, now, I don't have to follow that rule when I'm using these brass sets or a circuit board holder because you've got clearance to do that. But if you're building without anything, then yeah, you should continue to follow the let's build things closest to the thing and try to keep the board consistently at some height when you're soldering. So I'm going to pull these leads and I'm going to cut them off. These most inductors come on paper tape spools, so I cut the spools off. Again, I'm doing the same thing. I keep my spare finger over them. I'll take all four of these guys. They're the same thing. They're at 4/10 of an inch. That big red one's going to be a little bit hard to. I'm just sort of using it as a guide. It doesn't fit in the slot in the forming tool, so I sort of put it in the general vicinity and then. Now this is where it's handy. You got to remember your color code. In this case, I'm going to look at that and I'm going to see a red. Now I have the parts list memorized, and there's only one red. It's called red. It's red black, I believe, which is a 2.2. Is it red black?
Red gold.
Red gold. And I'm looking at red gold right there, which is a 2.2. So I'll go find where the 2.2 is, which is over by the crystal. Put that in place. Seat it down. Bend the leads apart so it stays put. Turn the board over. I got another one. This is a black brown. That happens to be a 10 microfarad. So I know that's on the top side of the transistor. So you're a little bit off. I'm a little bit off. I'm sorry. A little bit off camera, I've been told. I wandered into the woods here. So here's your 10 microhenry right here. So I'll put those in the two things, two pads, spread it a little bit. And I got this one here is a blue. Well, the first line is blue. That's a is it blue or is it green?
Probably green.
I think it's green blue. Okay, so I know that is the 56, which is over here in the filter. 0.56. Yeah. So that's the nice thing about this. There's only a few of each. So when you see 5/6, you need to put it in the 56. And of course, that leaves the last one, which is the funky one. That's the 0.47 over here in the filter. So I'll put that down there in the filter. Seat it down. Probably don't really have to spread the leads, but I'm going to do it anyway. So now I can, again, now I'm going to go clean my tip. Add a little solder to the very end. So I got a nice little heat transfer point. Go in there, set it a second, give it a little bit of a feed, and this is what's important, be able to move the board all around, because when you have a sea of leads, sometimes you got to get the solder and the iron into the place you want it to be. So that's pretty handy to be able to spin it around. If you had a board holder that weighed 5 pounds and it's clunky as all get out, this job would be much more difficult. Okay, so I'm winding my way into the right spot, through the sea of leads. Put that bead on the part and notice when it wicks, and just give it just a little extra. I spin it all the way around. I get this last guy. 1, 2. Everybody soldered? 1, 2, 3, 4, 5, 6, 7, 8. So I got 8 leads, 8 solder points. I can cut them all off. in my pile and get ready for the next part. Decide what I need to do. All the flat resistors, so I'm going to go after the capacitors, I guess. I'll take this little single and get him out of the way because he is a 471. It happens to be in the middle of the filter. Those leads are already formed, so again, I hold it in to the board with my finger so that I know that it's in the spot that I want it to be. And then spread these leads just a little bit. And it's held in place. Looks good. Okay. I'll go after the other one here, is the other single.
Which one is that?
I'm not even looking at it because I can't read it without my without some more light. It's a single, and it should be the
470?
no, we just put the 470 in, didn't we?
I'm sorry, 68?
Yeah, the 68. Remember I said it was the big 68, which goes right next to the 0.47. Okay, so there's a 68 in there. Spread a little bit. And I'm going to go after the 220 because the 220s go in the filter area, which is where I'm working. I'll cut all three of those off the strip. So we've got a 220 at the input of the filter. I happen to know that because, of course, I remember the schematic. I have it ingrained in my head from laying out the board and doing the documents 14 times. And the third one goes over by the transistor. There's a 220 there. Now I can elect to keep on populating the other ones, but I've already got 4 parts in there, so I might as well go ahead and build it up. Clean the tip of the iron. Add a nice, you can see it's nice and shiny. Nice little dollop. And I can put that in there. I wait a second. Add a little feed to it, and then away it goes. I'm kind of counting in my head how many leads I've soldered. I still got 2 more down here. And back down in this area. Whoops, one guy over here in the waiting in the wings. Clean. Little dollop. There's one. And I think they're all done. So I'll go and flush cut these. Whoops, look at that. I can see cutting them all off. I missed one. Right there. Don't want to cut him off until I get him properly soldered. Okay, so we're looking pretty good. Got most of the capacitors in. We will add the other 3.1s. There's a 0.1 here. One here. And where's the last 0.1? Huh. I must have kitted an extra one. We've run out of places to put a 0.1 capacitor. Yikes, looks like everybody must get a freebie. Okay. One.
Yeah, I only see 2 on the screen.
Yep. I kidded him late at night, so I must have counted them like the 223s because there's 3 of those. One,
Yep, yeah,
2.
there's 3 on the.
Yep.
2 on the schematic.
So I made a mistake. I think that's the first one I've ever done. Mistake.
I thought I was wrong.
Yeah, I thought I was wrong, but okay. So there we got 0.1. So hey, you get a free extra 0.1 capacitor out of it. Okay, so we're running out of parts to put in there. Now we got crystal socket. Oh, that might be a handy thing. You can use that for. Okay. We're gonna put there's 2 places to put a little 2-pin connector. Okay. Now they don't stay in and you can't bend them because they're much bigger. So in this case, what I'm going to do is I'm going to put the socket on top of it, make it a connection. Okay. Because if I tried to hold that down with my finger when I solder it, okay, so I'm going to put my finger on top of it. And so now I could, oops, I got that one lead in here I forgot to cut off. Okay, so I got to do that all over again. I got to put the shell connector, shell connector. I put it in there. Then I can hold it in with my finger, and now I can solder it. This is where it's handy to have a third hand or have a little bit more experience. So in this case, what I'm going to do is I'm going to take my iron. I'm going to put it on my actual solder cup cleaner thing. I'm going to put a little tip on it. I'm going to come in underneath. And I soldered that one lead. And I didn't burn my finger because I had an insulator on the top. So now I can take that off. I can go back. I can pick up the iron and solder the second lead. Second pin on that connector. Okay, that's soldered nice. Now, that first one might not have been all that great, so I can just go back and just give it a little touch-up job. And there's that connector all nice and soldered without burning your fingers. Big connectors with have 5 or 10 or 8 or whatever connections on them is not a problem typically because you can get your finger on one end and not touch it with the iron so you don't get burned. But when you only have 2 pins, it's pretty hard to hold on to it. And I've lost oh, here it is right here. So I'm going to put on the second one. Same thing. I'll put the shell on it. I will drop it right next to that oh, that's going to stay put because it's actually rubbing up against the choke and it's going to stay put. So, oh, voila, we've got a bonus here. You don't have to actually go and do all that craziness. Now, I'll tell you, this is a good reason for having a clean iron, clean solder, because you don't get a lot of dirt buildup on the iron. So you don't have to clean it as much. If you've got crappy solder or a dirty iron, you're going to find that your connections are not going to be all that great. And you have to clean the iron a lot more. Always take care of your iron and your solder. The other thing you don't want to do is if you got an iron that you're using for soldering, you don't melt plastic with it. You don't wood burn with it. Oh, I'm over there. Sorry about that. You don't you solder with a soldering iron. You do not melt plastic. You do not burn wood, your initials or anything else. I mean, you save that for a crappy iron. Get one that costs $4 and melt plastic with that. Don't melt it with a good soldering iron. Okay, so we got most of that stuff down. Now we've got down to this little socket for the crystal. You could actually, one secret is to plug the crystal in, okay, to the socket. And then, whoops, I missed it. Missed one pin. I almost got myself inoculated. I'm going to get inoculated next Thursday. I don't want to come early. Okay, here we go. So I can put that in there and do the same thing. I could hold on to the crystal and do the same technique. And the other thing you can do is you can actually, all you're trying to do is get one pin connected. So look at that. I can, it's almost a perfect fit. And I'm going to just do one pin. I'll let it cool. I'll take a look, and if I like the way it's situated, okay, it's pretty much straight up and down. I kind of like what it looks like, so I can go back and do the other two pins. There's number one. There's number two. And now that those two are cool and now holding the connector, I'll go back and do that first pin. That might have been a little bit on the schlocky side. So there you go. There's those three pins. I'm going to take the crystal out just because it's in the way. And so what we got left on here, we got this connector over here, and we got the transistor. So we'll go after the transistor next. Have to bend the leads a little bit. Nice to have some fingernails. Okay. And put them in order so that you bend properly. Now, some people jam that all the way down. I do not like to jam transistors all the way down. I like to keep them at least 1/4 inch off the board, because later on, if you need to change that transistor, it's easier to cut the leads high off the board and unsolder it one pin at a time. I'll do the same thing. I'm gonna bend them over a little bit so it stays exactly where I put it. Clean the iron. Put a little dollop. I'm gonna do all three transistor leads at the same time. 1, 2, 3. So the transistor's done. I can cut those leads off. I'm going to cut the leads off that crystal post because they're sticking out at least 1/8 of an inch there, so I can cut them off. And I'm looking down the edge of the board to see if I see anything else that's sticking up, and I say, no, it looks good. So there is just about everything except for the power connector. Now, this is a way of getting a cheap switch. So I'm going to do the same thing. I'm going to put that thing in there. I'm going to take one of the little jumpers, and I'm going to put it on the two posts. And this is the important thing. You got to remember which post you put it on, because that's what you're going to hold with your finger. I'm going to clean the iron. I'm going to put it in my area. I'm going to put a little dollop on the end. Now I'm going to hold on to the jumper that I put in there, and move the other pin, the third pin that I'm not touching. And there I put a little solder on there. Wait for a second. I'm going to look at it. It's leaning in a little bit. So I'm going to now sort of adjust it just by giving it a little bit of heat. And now I say, oh, that's perfectly straight up and down. I like it, so I can go after the other two pins. And so I'll do the far away pin, middle pin. Now I'm not going to touch that third one, because now that everything is all soldered and now cooled down, then I'm just going to touch up that first pin just so I know it's got a good connection. And there's that connector. I'm going to cut off the excess pins. And that is pretty much everything, except for we got to put the battery connector in, and we got to build the key. I'm going to take these guys off for a sec. Probably won't have to use those again. I'm going to take the end of this board. This cuts off like that. That's going to be the key. And we got the battery connections. One of the things I do, just so happens every once in a while I get a nice dead battery. This was in my voltometer, and I marked it dead. I put a little tombstone with a cross and an RIP on it, so I know it's dead. I keep that around on my bench for a good reason, so I can take those pins and put them on a dead battery. If I shorted them together, it probably wouldn't do much. If that was a 9-volt battery, it would do a little bit more. So in this case, I can put those in and I can look at the plus on the battery. I can see the plus over here, and I can put those into their holes on the board. I can set it right on the battery. I'm going to put a little block over here to raise it up. That's good enough. And now I can solder all 6 of those battery connections. Now you want a little bit of heavy solder on these because they're going to be stressed when you insert and unplug batteries. So I'm going to add, lots of extra solder for those. Not so there's big mounds of solder, but I'm just going to make sure that it's not a super light connection and it's got a good amount of solder holding that connection true. Just double check, make sure that they're looking good on the other side. And you see this action okay, Steve?
Yep.
Okay. And I got,
keep it on the blue tape.
Whoops, yeah, there we go. Okay, I got one more. You can see I'm feeding a good deal of solder in there because I want that to be a really as much of a mechanical connection as I possibly can. I'm going to switch this guy to the off position, which I should have done in the first place. But I got a dead battery, so I can take the battery off now. And you can see I got perfectly aligned connections. So now we can build the key up, and this key goes on the base. I believe it shows. Pardon?
Down towards you.
Okay. That's just the contact. So we can put the one little screw in there. Let me get a little Phillips screwdriver. Tighten that up. And the other one goes through the top of the key. Goes through 3 washers. A skinny. Oops. Get some of this stuff out of the way. A skinny and 2 fat washers. And the reason I have the spacing is just to make the right height above that contact screw or bolt. And I'm off. Oh, there we go. Sorry about that. Okay. Hope you didn't miss much. Okay, so I can I'm going to put my fingernail there, and then I'm holding this bolt on the nut on the other side. I can tighten that down. And looking at it from the side, you can see that it's got just a nice small gap. So there is. Oh, we back in?
Yep.
We back online? Okay, so we got it pretty much all built up. We can put the crystal in. The second jumper for this project goes over here. Okay, it's a shorting jumper. So when the jumper is in, the crystal is shorted directly to ground, and it transmits on one frequency right around 14.0. What have I got in here for a crystal? 14.060. If I take that out, now the crystal goes through the inductor to ground, and it oscillates at a different frequency. So you basically, out of one crystal, get 2 different frequencies to transmit on. Oh, okay, I'm over there again. So, and the other connector is just a cheap switch. You can put it over here. Now it turns it on, and you can operate the transmitter, and you put it over in the off position, and now you've stored it for travel, and it won't be transmitting if you accidentally put the key down. This connector right here. We're back over here. Okay. Over here we have a 51 ohm resistor, which is on the output of the low pass filter. So that is your dummy load. So if you transmit now, let's put a fresh battery in here. Unfortunately, I didn't. Okay, we're back from another break. Here's a nice fresh 9-volt battery. We can put this in, snap it in. I got the little switch to off. So there's a little, I can take the crystal off when I'm moving around so that way it doesn't get all bent up. Put the crystal in the socket. You can shave those leads down so it's shorter. I can then put it on and operate the transmit key. Now I've got a 51 ohm resistor on the output of the filter, which is in essence a dummy load. If you want to actually transmit, I mean, if with that dummy load in, if I had a world band radio on my bench, I could hear this oscillator. I could hear the code. Okay. So use the key, and you can use a local code practice oscillator. Okay. If I want to, I'm over there again. Okay, I'll get the hang of this one of these days. Okay, if I want to, I could pull that resistor or pull one lead of the resistor and put a wire over here and take that off to an antenna, and I can actually transmit into an amateur radio transmitter, 20-meter transmitter. And I mean, we're not putting out much power. This thing puts out about maybe 35 milliwatts of real raw power. But it's a nice little rig that you can actually work with. There are QRPers who say, okay, 5 watts is my legal limit. There are other QRPers who say, I'm not going to transmit with more than 1 watt. And there are the serious guys who say, I'm not going to transmit with more than 100 milliwatts. Those are the real nutcases. No, they're actually, I mean, it's a challenge. And, it's how much fun you get out of radio is what challenges you put upon yourself and how you enjoy that meeting the challenge. Some people like really small radios. I happen to like really small radios. Anyway, so that's how we built the 20-meter sender. You probably would want to put 4 little rubber feet on there so it sits down on something nice and neat, or you could put it in a little case, but with the key built in, hard to say. I give you the kit, you put it someplace else. Thank you very much. Hope you enjoy your build.